Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 2009, Acids and Bases, Part 3. Here are our objectives for today's video. Pause here. So percent association is just going to be a way to conceptualize how strong an acid is. So that would be the amount dissociated, typically measured in moles or in molarity, over the initial concentration times 100, just to make it a percentage. In general, acids that have high equilibrium expressions, we're going to have high percent association, which logically makes sense. But the second point sometimes doesn't logically make sense to students the first time they hear this. So at higher concentrations, the percent association of an acid is going to decrease. So what that means is if I have 10 molar acetic acid versus the 1 molar, that 1 molar is actually going to have a higher percentage dissociated. The reason why that makes sense is that at higher concentrations, you've got higher concentrations of your H3O and your conjugate base. And so because you've increased the concentration of your products, you're actually increasing the rate of the backwards reaction, which effectively means that the equilibrium position is going to be different. Pause here. So this entire video is really just going to be this example, so you can see how all of this works together. So this right here, I just copied and pasted from a prior video since we've already actually worked with acetic acid before. I'm going to show you how we do a hydronium ion concentration. So this is an icebox problem. So we know it's 0.0100 molar. You can assume that the other things are 0 minus x So I'm going to make the assumption that because my equilibrium constant is so low, that 0.0100 minus x is approximately equal to 0.0100. Right, so now that I've solved for x, that is equal to my hydronium ion concentration. All right, now for my percent dissociation. So I have 4.20 times 10 to the negative fourth. That is my amount that is dissociated over my 0.011. And I just need to make that into a percentage. So I've got 4.20%. If I were to do the same problem but at a higher concentration, my percent dissociation would be lower. And now for the third part of the problem, which is something that pops up very frequently, these types of problems. So for the pH, I just take the value I got in part A and I take the negative log of it. And then POH is even easier, just 14 minus that. And then here is the problem set for today's video. Thank you so much for watching and have a great night.